Hello viewers, before we begin the main video I want to apologise for what I consider to be an incomplete video. I had planned for it to have two sections, the first looking at the HAL hardware and the second part looking at how the software differs from the Paintbox. Unfortunately I ran out of time because I had to take the HAL back to its owner, so I was not able to make the second part. So sorry for the abrupt ending, and I hope you enjoy looking at the HAL hardware. Hello viewers, welcome back to the lab. Now I've just been working on a Quantel HAL for somebody who asked me to take a look at it, see if I could get it working, and I have got it into a basic working state, and it means it's going to be leaving the lab. So I thought I'd take this opportunity to run through it with you lot, and you can see what the Quantel HAL is all about. But before we do that, I just wanted to mention that I do have a Patreon account, and there has been 3 patrons consistently putting some money into my account for a very long time. So what I want to do is thank those 3 patrons for all their support over the, I don't know, it must be a couple of years now it's been active. So thank you very much to them. I'd also like to take this opportunity to say, if you do like watching my videos and you want to try and help support the channel, then I would welcome any more patrons to the fold. Even just £1, $1 or €1 a month can sort of build a little fund to help buy things. You know, that might be things to tear down or Quantel parts, things like that. So if you feel so inclined, then feel free. The link to the Patreon website is in the video description. Okay, so the HAL, it belongs to a really nice chap who has the largest private collection of computers here in the UK, and I was talking to him about some other stuff, and he mentioned he had a HAL and wondered if I might be able to do something with it. So I went and picked it up, and I also took up there the hard disk from the DPB 7001 classic Paintbox that I've got. If you recall that, it's a large Fujitsu drive, 14 inches, and he's going to try and get some data off it, but that's still work in progress. So I went up there, picked up his HAL, dropped off my hard disk, and I've slowly been working on the HAL to get it into somewhat of a working state. It's not fully functional, but it's a lot better than what it was. Now, unfortunately, he only had the system chassis, or the crate as Quantel call them. He had no peripherals of any kind, so I've had to source things like tablets, keyboards, pens, interfaces, grips, and most importantly, a DL147 disk array which works with the HAL to store all the video. So that's been quite a task, but we have a system that can be demonstrated to people. You couldn't actually use it as a usable thing because there's a few faults with it, but for a computer collection it's probably perfect. So anyway, let's get on with looking at this. It's not on the table, as you probably guessed. It's sat next to me, and it's going to stay there. I'm going to move the camera in a moment and you can take a look at it, because unfortunately the whole lot probably weighs about 90 kilos, so there's no chance it's going to get up onto the table. Right, well here we are. The HAL here is on the top, and then the disk array for it is underneath. As you can see, these are rather large units. They never offered these in desk side format like they did with the Paintbox, so these are only rack mount. So what is a Quantel HAL? Right, like all the other systems from Quantel from the late 1980s, it is based on the V-series architecture, so it shares a lot with the Paintbox. If you've seen my other videos, you will know that a standard Paintbox only works with single pictures. It doesn't do video. My own personal system, which is just down there, is a Harriet, which is a combination of a Paintbox and a ramcorder. Quantel dubbed this combination as an animation over video system. It allowed you to record 12 seconds of video into the ramcorder and then composite animated content over the top of it, or use it as rotoscoping. So the images and stuff that went over the top of the video were essentially static. Although you could sort of bend and warp them and do various things with them, it couldn't show sort of moving video in those things. That's the difference with HAL. HAL expands on this. Instead of using the RAM recorder, which was just simply a RAM store, and it was only 256 megabytes, the HAL uses a disk array instead of the RAM recorder, so it allows you to record large amounts of video and then play back that video as clips on top of whatever you're compositing on top of. So you can create these loops of lots and lots of different effects over the top of each other, each with video, sort of to create the effect that you want. Now this particular HAL is a HAL Express. In the 1990s, Quantel upgraded all of their machines to the Express models, which switched out the older 68010 based CPU board for the 68040 and had expanded RAM as well. The disk store card is also upgraded from 6 megabytes to 24. This also allows it to run the Express version of the software with much enhanced features. The HAL also includes a new bitmap processing card. Like the other Paintbox systems, there is always a card that does some hardware manipulation of bitmaps. There are 5 types. There are size, rotation, perspective, cap and image. There could well be more, but that's just what I know about at the moment. The HAL uses an image card, which Quantel introduced around about 1995 it seems. It's an upgrade to the cap card. It's quite impressive, which I will show you later when we look at the rest of the system. So the biggest enhancements with the HAL, as I mentioned, is record and playback video. This is done with uncompressed data as a BT601 video, which is essentially SDI, at 270 megabits a second, and records to the disk array. The disk array actually provides up to 15 minutes of video, although that is actually software limited by the HAL itself. The disk arrays, I believe, are all the same, and it's literally down to the software keys on the HAL which determine how much storage space you have on the disk array. The other difference to the Harriet is it will also record audio along with the video. The clips in the HAL also include a stencil or key channel, so you can key video clips over the top of other clips. In fact, you can composite up to 99 video clips or images with 3D effects in one pass with key channels on them as well. Of course, because this records video uncompressed, you can create effects in multiple passes, just like I can on my Harriet. And of course you have all the animation features found on my Harriet system, but also includes keyframe features on the Kia for creating video key channel and effects functions, allowing keyframe adjustments for effects and all sorts of stuff. That is different from my Harriet. Unfortunately, I can't do that. Right, so it's probably about time we actually take a closer look at this. So as we can see, it's 2 parts. We've got the HAL and the disk array. The disk array is a 4U crate and the HAL is 5. Right, the front panels just unclip. They just come off. They would have had some filters in the back. So if anybody remembers the edit box system that I took apart, these are very similar to that. They have a top cover which slides off. Right, so let's take a look in the top. Obviously we've got a nice big power supply. That's a Lambda unit, delivers 60 amps, 5 volts 60 amps, another 5 volts at 25 amps, another 5.2 volts at 25 amps, 12 volts at 12 amps, and another 2 12 volts at 6 amps each. So these will probably be mixed up in a plus minus configuration, so there's probably plus minus 5, plus minus 12 possibly. There's all the power connections on the back there. There's a large back plane which runs down the back of the system to connect all the cards which are in the side here, which I'll show you in just a moment. On the back here we've got this board here which handles all of the SDI video inputs and outputs. So on previous systems, Quantel had these actually built onto the video output boards, but on these particular systems they moved them up onto this separate board and did the SDI conversion just there. We've got a couple of system disks. One is the main operating system disk, etc., and the other one is the shared disk, which is essentially the network drive. So anything that gets shared with other people over the network gets stored on that disk. Right at the front we've got an MO drive that is a 2.6 gigabyte, if I recall. So it's sort of middle of the range size. Okay, in the side here we have these panels which just come off with just a few screws and just easily removed. There's a little legend thing on the inside showing you, get it the right way up, showing you where all the cards are supposed to go. So what I'll do, I'll just take out each of these cards and I'll just talk about what I know about them. Some of the cards I know quite a bit about, but some of them it's a bit vague, unfortunately. So let's just disconnect these wires here. That's the network cable and then earth cable. So the top card is always the CPU card. So that's the later generation CPU 42, or is it 43? CPU 43, sorry. So this is a 68040 based system. It's pretty much complete. If you put power on this, it will power up. It doesn't actually need to be plugged into anything. That's literally just the buses out to Quantel's backplane and stuff. So this is a complete 68040 system. We've got DMA controller on there and 64 megabytes of RAM. We have real-time clock and an NVRAM IC just there with the snap-on batteries. And that's pretty much it. Various configuration switches for changing the serial ports to be either RS232 or RS422, depending on how you're going to use it. So next card down is blank. This particular architecture, the way they use this on other systems like the edit box and things like Henry, this was populated with another CPU card. But on HAL it's not used, so this is just sort of like a termination board, so it doesn't really do anything at all. Next card down is the netcom board. So this provides all the networking interface. We've got a 100 base T Ethernet on there. The system is completely standalone. So there's a 68,000 based CPU on here with its own RAM, with its own clock, NVRAM, all that sort of stuff. So it's completely separate from the other CPU board. The two talk to each other over SCSI. On pretty much all of the Quantel systems there are two SCSI channels, A and B, and the CPU can talk to the netcom board over one of the SCSI channels, which allows it in turn to get access to the shared disk, because the software for this card is on the shared disk on here, and the main system software is on this disk, which is for the main CPU card. So quite a complex system, but that's okay. The next card is input select. So this is essentially replacing the video input card of the Paintbox. So this does have all the analog video inputs on it, but it doesn't have the digital video because that's on that top board that I showed you earlier. So quite an old school all through hole. Oh, it's not, no, there's a few surface mount on there, but it's mostly through hole. I think this system dates from the 1995, something like that. Let's see if we can see some date codes. 1994. So yeah. But as with all these Quantel systems, you tend to find that all the systems have a bit of mishmash of dates on all the cards. I think as things broke and were replaced, they would replace with newer cards in old systems, and old cards got refurbished and reused. So there's often a bit of a mishmash of dates in systems. That's that board. Next card down is APE, and that is, as far as I know, the audio processing card. So the HAL, although it does do audio, it doesn't do analog audio. It only does digital. There's 2 ports on the back which provide 4 channels of digital video that they call AES EBU, which I think is pretty much SPDIF, but in a different physical form. So that's the board that does that. We've got a bit of RAM on there. The audio, I'm not sure exactly where it's actually recorded. It could well be on the system disk, but it might be encoded along with the video on the disk array. Okay, next card down is probably the most important one in the system, because this is quite an impressive board. This is the image card that I mentioned to you earlier. This replaces the CAP card, which does enables the functions that allow you to do all the 3D effects, 3D warps, all that sort of stuff. The older card was basically based on an InMOS transputer. Now this does have the same InMOS transputer down there in the bottom corner, but it's mostly made up of Altera Flex PLDs and these 3 multi-purpose ICs which can do image filtering and various other functions as well. So I believe they're using this as almost like a software programmable GPU kind of thing. I think it gets reprogrammed depending on whatever task it's doing. So quite an impressive board. This one's dated 1995. So quite an impressive thing. It's a 10-layer PCB as well. So very impressive looking board. Next card down is the disk store. So this is very much a completely bog standard Quantel Paintbox disk store board. So you'll see, if you take apart any Quantel Paintbox, you'll probably find one of these. And the next card down is the disk store board. Again, very common board in paint boxes. You're going to see one of these if you ever take one to pieces. So yeah, very common. Next card is the output video card. So this is effectively equivalent of the video output boards that you see in a normal paint box. But it doesn't have the digital video outputs on it because, again, I said they're handled with that board on top of the actual HAL. So this is only the analog video and some of the video processing for the digital side. So if we have a little bit of a closer look at this, we've got 2 video output modules, both analog. Down on this corner, this little board actually provides the actual hardware cursor, which is on the screen. So that's the actual little board that superimposes your cursor on the screen. So this card is called the LH MUX, and it is certainly part of the interface into the disk array that's used to store the video. there's several cards that that seem to work and do things with the disk array. This is just one of them. So that's that. So this is the actual connection out to the disk array. I'll show you the actual connections in a moment, but this is the actual link to the disk array. Also on here, I should note that there's an InMOS serial link, which allows a special InMOS link to InMOS transputers. The disk array actually uses one of those, so all the communication is sent over this InMOS serial link, which is provided by that IC there. So it looks like this side sort of does the actual video communication with the array, and then this bit does the actual control communication with the disk array. So put that back in there. Then we have an empty slot, and then we have another card, and this one is called Disk Link. So again, this is going to be more of the communication with the disk array. Not a huge amount to see on there. Interesting card, this one. It's called Router, and I think what Quantel actually doing here are intercepting what would be the video signals between the input and output video cards, the disk store and main store cards, and the image card, and inserting the video from the disk array. And this board does the switching between the different inputs and outputs. So although things like the main store, disk store are largely compatible with everything else, all other paint boxes, they obviously add this extra layer on top to allow the HAL to switch video into the system and actually manipulate it. So I think that's what this card's doing. And next one down is called Video Proc 2B. Another fairly impressive board. Now I think what is actually happening on this board is they do a lot of the more of the video processing. The HAL is one of those Quantel systems that can do image following, so you can define an area of an image and the system will track and follow it to allow you to animated things that follow sections of video. You know, you can like overlay things over the top of other bits of video and do that automatically. So I think that's partly what's happening on this card. And the last card to look at is the Key 2 ST card. I believe this is doing some processing of image keying, you know, keying one image over the top of the other with the key channel. So there's obviously a fair bit of processing going on there. Quite a few custom Quantel chips with obviously being made by Atmel. That's these ones here. A couple of logic devices, 2550s. Those are convolution matrix filtery things, so that's done in hardware. Again, that might be to do with the image following, or ALF as Quantel call it. They might be using edge detection and stuff with those. So it's got a fairly interesting board, and that is pretty much it. The last card is just a termination board. There's not really anything on there apart from a couple of resistors. So if we have a quick look at the back of the system, we've got the various connections out to the tablets, the serial ports for controlling VTR machines. We've got the 4 video inputs, 4 video outputs, audio connections down at the bottom, and we have an analog input and an analog output. We've also got a couple of SCSI ports as well. They generally don't get used, but they just give access to the 2 SCSI buses in the system. We've got network port on the end there, and then this cable here is the one that actually goes out to the disk array. And this is a 100-way micro D connector, sort of similar to what you'd see on the full spec SCSI 2, I believe. Right, let's move the HAL out the way and I will give you a look at the disc array. Right, this is the disc array. These are known as a DL2. There is also a DL1. The DL2 is just a newer generation. It replaced the old one. So it's just a large array, but if we look in the top here, we've got rather large control board, big power supply in the middle and a set of fans. So this is a disc array of 20 3.5 inch 50 pin SCSI discs. Each one has its own connection and its own SCSI controller. So they are all set to ID0. They're all on 20 independent SCSI channels. The discs are Fujitsu 1.2 gigabyte drives, which gives you a total capacity of about 24 gigabytes. Now, one important little detail with these disc array and the HAL is there is not really any structure recorded on the actual discs itself of video clips. It's literally just raw video. All the structure is recorded on the HAL itself. To load a clip, you load up a small file on the HAL and that just references the video frames which are stored on the disc array. So if you take one disc array and plug it into another HAL, all the video will be completely screwed up and it won't know where anything is. It just expects to see, frame number 10,123 to be the start of a particular clip. So if you swap in a different disc array, it will just end up playing some random bit of video probably. So the actual video, as far as we can tell, is literally raw video, as it would normally be sent to the video output cards. So in the case of Quantel, that is 16-bit YUV, so it's not even full 10-bit Rec 601. So there's a slight saving in bandwidth there by only recording YUV 16 video data. From what we can tell, it's pretty much clocked into the system, and then the HAL requests to the controller CPU, which is over there in the far corner, to do a disk write, and that writes that frame to the disk. The CPU also keeps a track of how fast the disks respond to those requests and keeps a log and a tally of how the disks are performing. Interestingly, it actually keeps a log. It grades them in lemons. So the higher the lemon count on a drive, the slower it is. Now, you wouldn't notice this difference if you just had it plugged into your normal PC. It would just work fine. But for a system like this, where you're recording a lot of video in parallel over many disks, you can find that some disks are slightly faster and slower than others, and that can cause problems. If one doesn't respond quite in time, then the data doesn't get sent out to the HAL in time, and you get slight bits of video corruption, and that is partly what we're seeing now. I think I've got all the disks working fine, but I think there might also be some other issues on this, and it's not outputting quite right, so there are some little artifacts on the recorded video, which is a bit of a shame, but that's pretty much the best I can do with what I've got. So, as I said, we believe that the video data is literally just clocked into this entire system through this bank of custom programmable logic over here. Now, I think what this is doing is actually computing an error correction code, because there is one of these disks which holds some parity and error correction information. So that does mean that if one disk fails, the system will actually carry on, and you can replace that disk and it will rebuild the data. So it's obviously a redundant system. I think that's computed by these bits here. Now, one thing that is quite interesting about this system, when I first got this, a couple of the drives were dead in it, and have replaced them with some spares that I had Now I found that as soon as I swapped a disk, the system just popped up and said a disk serial number has changed, and then shut the system down and basically said you can't do anything. At the time I thought it was more to do with getting Quantel's customers to buy service contracts and only get the discs from Quantel and have Quantel engineers come out and fix your system. Now I don't think that's strictly true actually, but the system does keep a track of serial numbers. So at the time I had no idea how to fix this, and I actually spent quite a bit of time trying to figure out where the serial numbers were stored and how they were stored and logged, and I found a small EEPROM on the board, and I actually took it off, read it out, and sort of reverse engineered how it encoded all the serial numbers of the discs into that EEPROM, and kept a log of them. So I actually have this on a little plug-in board so I could actually take it out and reprogram it. Now shortly after that I did actually find some documentation which actually describes how to actually do all this from the debug console on the HAL anyway, so that ended up being a bit redundant, but it was an enjoyable experience going through and trying to reverse engineer something. So that I could probably solder that back onto the main board now. It's not really needed. Other little things on this board, if I zoom out a little bit, there's several banks of RAM on each of these drives. From what I've worked out, there's 2 megabytes of buffer storage on every single drive, and there is also 4 megabytes of RAM for the actual CPU that runs the system over there in the corner. That ceramic device over at the back there, that is the CPU. Now interestingly, there is no software for the CPU stored on the disk array at all. It's actually loaded over that InMOS serial link when the system boots up. So the disk array is pretty much dead, doesn't really do anything until it's connected to a HAL, and the HAL loads the software for the disk array into the system. Well, I'll just show you the hatch where the disks go. It's just in the side here with an aluminium cover over. So we've got a bank of 5 drives on the top, and then another bank of 5 underneath, and then that's doubled over on the other side. So if I just remove one of these, they're all installed on these little sleds, so they're easily replaceable, and these are just completely standard 1.2 gigabyte Fujitsu drives.